All right, welcome to Inverse Relations Part 3. What we're going to do is take a look at some of these functions, of which I've drawn one here. Let's say this is our function f of x. And the problem is when we find the inverse of this function, the inverse is not a function itself. It's just a relation. And is there something we can do about that so that the inverse is also a function? Well, let's have a look at the inverse graphically here. So here's my original function. And remember that the inverse can be determined by just reflecting across the line y equals x. So I've drawn the line y equals x, and I'm going to reflect the two parts of the parabola here across. So we're going to get on the one side, if we take the left side of the original parabola and we flip it across, it's going to look something like this. I'll just do a dotted version here. Whoops, there we go. Something like that. So that's the left side reflected across. Now I'm going to take this little right side here and I'm going to reflect it across. So there's this little guy here, and there's the point here on the line itself, y equals x, which doesn't move, and then it keeps going like that. So this is my graph of f inverse of x. So you can see clearly it's not going to be considered a function because it's failing the vertical line tests just about everywhere. But what could we do to make it a function? Well, the answer is very simple. Suppose I only had half of the original function, the original parabola. Let's say I only had this part here on the left side. Then the only part of my inverse that I would have is this guy over here on the bottom, and that would be a function because there's only the one part of the graph. So what I could do is I could stipulate, and I'll show you a mini version of what I'm talking about over here. I could stipulate I only want this side of the original function. And here's how I do that. I just say x's that are to the left of 0, 0 being where the vertex is here at 0, 0. So I'm saying, yep, to the left side of that 0 only. And that would mean that my inverse is going to be this guy over here. Okay, and that would be a function. Or I could do the following. So that's one cure. The other cure is to say, why don't we just keep the right side, or the positive side, and we would do that by saying we want x's greater than or equal to 0. And that would mean that the inverse is just this part of it, just the upper reflection, and so that too is a function. So either or would ensure that I have an inverse that is a function. So how do we decide which is which and what to do? Well, let me do an example for you and I'll show you what's involved. So let's clear the screen. And let's say we have the original function looking something like this. So I'm actually going to give you the function f of x equals 2 and then times x plus 1 squared minus 3. Now, before I get carried away, since to split a function to have a left side or a right side, it's really important to know where's the vertex. If you don't know where the vertex is, then it makes it quite difficult to know how to split this thing. And the only part of the vertex I'm really interested in anyway is the x part of it. And that is where it is going to turn this stuff in brackets to 0, and that would be at -1. So that's the important part of the vertex. So that's kind of an important aspect. Now I'm going to start to look for the inverse, see what it looks like. Okay, so this would have been a y. So I'm going to switch that and make that an x. And over here, I'm going to make that x a y. And now I'm going to carry on and solve for y. So I'm going to add 3 over. Okay, then I'm going to divide by 2 so I have a fraction, that's okay, equals y plus 1 squared. Now I'm going to square root both sides, and this is when I do this, that's when the plus or minus thing kicks in. Okay, and that gets rid of the squaring. And then lastly, I'm going to add 1 over, or sorry, subtract 1 over. So here's what my inverse function should look like. Now, there it is. And so this technically is the relation f inverse of x. So now I want to make sure that I have a function. So I have basically two possibilities. So let's see, I've got enough room over here. On the one hand, I could decide to use the left side of the parabola. So that would be x's that are less than or equal to -1. So essentially, if I did like a very basic little graph over here, and that is a small graph, but anyway, doesn't really matter. -1, -3 would have been the vertex, so we're down here with the vertex. There is a +2 in front of the whole thing, so I know it's going to open up. And most importantly, I've reduced it to x's that are less than or equal to -1. So we're actually just talking about the left side. Okay, so there's the original function. That's all we're keeping. So where is my reflection going to be? Well, typically, if you're flipping the left side of the parabola and you're reflecting it across, let's see, maybe I'll just get a little bit of a foothold here, and so I don't clutter it too badly. I'm going to draw that my inverse underneath. So I'll flip the -1, -3, so I want to be at -3, -1, so it kind of starts over here. And it's going to be the part that goes below, so it's doing this. So we use the dotted method, dotted graph. So there is my inverse. Okay, so again, if you reflected the original function across the line y equals x, you would get this graph over here. So now I got to decide which of these inverses is it. Is it the one that has -1 plus a number? Or is it -1 minus a number? Well, here's how you got to understand this. Okay, do a very basic graph here of the inverse relation. In the inverse relation, you're going to have a part that goes up and a part that goes below. Okay, we know we want the lower one, but which one is it? Is it -1 plus or -1 minus? Well, look at a point like if you plugged in, actually 0 doesn't work that well. What if we plugged in 1? If I plugged in +1 here, what would I get? So this is saying x is 1. Then y would look like this. I would get -1 plus or minus the square root of, and I'm plugging in 1. So 1 plus 3 is 4. 4 over 2. So I would have 1, then -1 plus the square root of 2. Boy, I didn't pick very good numbers there. Okay, let's go with it. The square root of 2 is approximately 1.4. So -1 plus 1.4 is positive 0.4. And the other y value is -1 minus 1.4, so it's approximately -2.4. All I want you to see is that when x is 1, we have a number that is above, where it sends us up to here, and we also have a number that sends us down below. Okay? So which one was it that went above? That was when we went -1 plus. So the upper half is the one that has the plus. The lower inverse function is the one that has minus. So to match this side here, where we have gone to the left, and then our reflection is the lower half, we want our inverse function to look like this. F of x equals -1 minus the square root of x plus 3 over 2. Okay, that's the one that matches the restricted domain. So now we go to the other possibility, which is we go to the right side of negative 1, and clearly the inverse function is going to be the one where it goes above. So we would use negative 1 plus the square root of x plus 3 over 2. And so that's how you decide which one matches the restrictions that you've chosen. So there's actually kind of two answers here. Well, I think that's pretty much the end of it. So that's where I'm going to stop looking at inverse functions.